right, guys, this is going to be the recording for Thermal Energy 3.1, and the entire theme of this lesson is that thermal energy is not temperature. So throughout this chapter and throughout this unit, can't really say chapter because it's the first lesson of chapter 3, but more throughout this unit, we've learned that molecules, the speed affects temperature and kinetic energy. So for example, if a substance or a sample is hot, it's going to have molecules that are moving faster. And since those molecules are moving fast, they're going to register a high temperature. And since they're also moving fast, they're going to have high kinetic energy. Because remember, kinetic energy has to do with movement. So if there's a lot of movement, they're going to have a higher energy. Vice versa, if something's cold, those molecules are not moving fast, so they're going to register a lower temperature. And since they're moving slow, they're not going to have as much kinetic energy either because there's not a lot of movement. But we're going to throw a wrench in this whole thing with thermal energy because it's a little different. So scrolling down, click on today's assignment. And for today's assignment, the first thing I'm going to have you do is look at this kind of model. And what you're going to do is in the gray boxes here, you are going to explain using words what would happen to the molecules and temperature of the air. And so what you see here is this column is the morning, and this column is going to be the afternoon. And so for the morning column, you can see there's a bunch of ones. Looking at the key over here, a 1 represents a slower molecule speed. And then we see over here, that means from this key that it has a low temperature. Same thing over here, we have the warm water below the school, which has molecules at a speed of 5, which over here is fast. So we can see the air is cold and the water below has fast moving molecules and it is hot. So think about, and you can look at these pictures under here, if I were to take this hot water and snake it through all these pipes in the school, either way, what would happen to the air? Think about our heat transfer from hot to cold. If the hot water is going through the pipes and I have cold air around it, that cold air is going to attract that heat and it's going to want that energy that those pipes are bringing through with that hot water. And so I want you to describe here, how are the molecules going to move? Are they going to be moving fast or slow in the afternoon? And we're talking about the air inside the school. Then down here, what's going to happen to the water after school? Think about it in terms of the fact that it's probably going to either have been used if it's groundwater, because remember the groundwater pumps up and through and then leaves. But the water heater will pump all the way through and come back through. But has it lost its energy? Has it lost its heat? Because think about how much energy is being transferred from that hot water in the pipes to the air around it. Then you'll see, like I already said, the pictures are here and you kind of want to look closely at them. Remember, we have different temperatures. The air is the same, but our water heater pump is 39 degrees and our groundwater is 30. And then you're going to look here. There are 2 questions. I want you to explain how the groundwater system is going to heat that air. What is happening to our molecules in the air? And I kind of already gave this away. And then what is your opinion right now? We've done some more learning. So what's your opinion about which of these 2 heating systems would do a better job of heating the school, and tell me why? Then there's a reading right here about why thermal energy is not temperature, and it puts a scenario of you and a sibling eating soup. And one sibling has a bowl of soup while the other sibling just has a mug. And so it's talking about how there's a difference in temperature. So the mug cooled a lot quicker and the bowl of soup stayed hot. And there's a few differences. I noticed that the bowl of soup has a lot more molecules and the cup has less. And so the fact that the bowl has more molecules means it has more thermal energy because there's more. And since there's more molecules, there's going to be more kinetic energy available because there's a lot more movement because there's just more. And then opposite in that mug, there's just less. There's only 5. And so they're not going to be able to get as much kinetic energy because thermal energy is the total kinetic energy. Okay, and you can see I highlighted it down here. And so you're going to want to read that and then tell me, what is thermal energy? And then down here, I want you to explain to me why the mug is cooling quicker than the bowl. And I explained that a little bit, but I want you to read and kind of figure that out. I would also like you to use the terms molecules, kinetic energy, and thermal energy in your explanation. And then there is a little challenge in the sim. So if you open up the simulation, what your challenge is while that's loading is I want you to create a cooler sample that has more kinetic energy than a warmer sample. So your sample that's cooler has more energy than your warmer sample, which is kind of against what we've been doing this whole time, but there is a way to make it happen. I'll give you a hint. The size is what makes a difference. And so I don't even actually need to open that simulation, but I want you to try to achieve that goal and tell me how you did it. And like I said, kind of gave you a hint here. And then the last thing is a brief little overview of what conductors and insulators are. And I have 2 videos right here that have some examples and some demonstrations on ways to figure out if it's a conductor or insulator and then what it is. So I have a spot here for you to tell me what each one is, and then 3 examples of each. And the main idea is that conductors let heat pass through them and they transfer heat, whereas insulators don't let the heat pass through and they kind of block it or keep it in. Example being, we have in our walls, we have insulation in our houses, and that's to keep the heat trapped in so it's not escaping to outside. Same thing, it keeps the cool in the air conditioning. So watch those videos on your own and turn this in when you are finished. And that's that.